Hello everyone, let us start with our question. In this question, what is given? A parallel plate capacitor of plate area capital A and separation is small d is charged to a potential difference of V. Now the battery is then disconnected. Okay. Now the slab of the a slab of dielectric constant K is then inserted between the plate of the capacitor so as to fill the space between the plate. Now if capital Q, E and W represent the magnitude of charge, electric field and the work on the system, we need to find whether which option would be correct. Okay, whether this or this. Okay. Now one thing we know, when we have connected the capacitor with the parallel plate through a potential difference V, what is the charge which would occur here? So Q value would be equals to what? Q value would be equals to what? C into V. Now what is the value of C? It would be epsilon A divided by D, and we can multiply it by V. So it would be epsilon A V by D. So this is charge, this is before in the initial situation. Now when we have disconnected the battery, whether the charge would change? Charge won't be changing. Why? Because charge would remain conserved. There is nothing to bring or to take the charge. So initial and final charge would remain same. So it would be epsilon A V divided by D. That means A option would be correct and B option is wrong. So this we can say that this is correct and this is wrong. Now we need to find what is the value of electric field. Okay. Now electric field, we know that electric field value after the discharging. Okay. We know that it would be V dash divided by D because we have not changed the value of the separation. It is D, and electric field is defined as the ratio of potential difference to D. Okay. Now what would be the value of the potential difference after we have inserted the dielectric? So we need to put this value. Okay. Now when after we have inserted the dielectric, we can say that C before, or we can say C into V. This is the initial situation. This is the value of charge, initial charge. That would be equals to final C into V. Now final, since we have inserted a dielectric, so final C value would be equals to K into C because it is getting K times by inserting the dielectric, and potential difference would be equals to V dash in the final situation. Okay. Now C and C would be gone. That means V dash would be equals to V divided by D. So we can just put the value. So it would be, sorry, V divided by K. V divided by K, not D. Okay. V divided by K. So what is this value? It would be equals to V divided by K into D. That means this option is also correct. Okay. This is correct. This is correct. Now what is the value of the work done? So we can calculate this also easily. How? So initially, what is the initial potential energy? Initial potential energy is what? We say that half into C into V square. And what is the value of the final potential energy? We say that it is equals to half into Kc. Why? Because capacitance in the final situation would be K times into final potential difference. Final potential difference is V dash, and we have calculated the value of V dash as V by K. So it would be V by K square simply. So we can say that it is equals to 1 divided by 2 C V square divided by K, because 1 power of K would get cancelled. So what is the change in the energy in this electrostatic energy? So UF minus UI, we find this is the change in the potential energy or electric potential energy of the capacitor. So we can take 1 divided by 2 and see V square to be common, and then it would be 1 divided by K minus 1, because it is also coming like this. It is half CV square would be common here and here. Okay. Now what is the work done? Work done is the negative of change in the potential energy. So we need to multiply this by a minus sign. So it would be half into CV square 1 minus 1 by K. This would be the work done. So let us check whether this is matching. So it is given in terms of epsilon. So we can just convert. Okay. So if we put the value of epsilon, so it would be epsilon A divided by D. Sorry, this is the value of capacitance. Okay. Now else what is there? There is 2. There is V square in the numerator, and there is 1 minus 1 divided by K. So what would be our answer? Epsilon A V square divided by 2D 1 minus 1 by K. So epsilon A V square divided by 2D 1 minus 1 by K. Okay, that means correct option are what? A option is the correct option, C option is the correct option, and D option is the correct option. So hope you have understood this explanation. Thank you. Hello everyone, let us start with our question. In this question, what is been asked? A parallel plate capacitor is charged and the charging battery is then disconnected. Now if the plate of the capacitor are moved further apart by means of insulating hand, okay, it is moved apart by means of insulating hand. So we need to tell whether charge increases or voltage increases or capacitance increases or electrostatic energy increases. We need to tell this. Okay. Now, for example, this is one of the plate we are just drawing. This is one of the plate. Okay. and let's assume that this is another plate. Now what we are doing, we are disconnecting the battery. That means the charge which has come here, for example plus q, the charge which has come here, for example minus q, this charge would be same. Okay, because charge would remains conserved. So if there is no external source to increase or decrease the charge, so the charge would remain same. That means charge on the capacitor increases. This is wrong. Okay, A statement is wrong. Now potential voltage across battery increases and capacitance increases. So first of all, we should write about the capacitance. So capacitance is written as what? So C equals to, we can write C equals to epsilon A divided by D. Okay. Now, if the separation is increasing, D is increasing. If D is increasing, then capacitance is what? Capacitance is decreasing. So capacitance is decreasing. This is wrong. Okay. Now, what to tell about the voltage? So voltage is written as what? V equals to, we know that V is equals to what? Q divided by C. Now we know that C is decreasing, so this is decreasing. So this is inversely proportional. Q is constant. Q is constant. So these are inversely proportional. So if C decreases, then V would increase. So we say that voltage across capacitor increases. This is correct. Now electrostatic energy stored in the capacitor increases. We need to find this. So how is electrostatic energy written? It is written as U equals to 1 divided by 2 Q square divided by C. It is written like this. Now if C is decreasing, now this factor is decreasing, so it is inversely proportional to C because Q is constant. So that means U would increase. So that means this option is also correct. So what are correct option? B option is the correct option and D option is the correct option in this case. So hope you have understood this explanation. Thank you.
Hello students, today our question is three identical capacitors C1, C2 have the capacitance and C3 1 microfarad each and they are uncharged initially and they are connected in circuit as figure shown in the figure. C1 is then filled completely with dielectric material of relative permittivity ER and the cell electromotive force EMF V0 is equals to 8 volt. First the switch S1 is closed while the switch S2 is kept open. When the capacitor C3 is fully charged, S1 is opened and S2 is closed. Simultaneously, when all capacitor reach equilibrium, the charge on C3 is found to be 5 microcoulomb. Then the value of ER, that is relative permittivities. So we have this is V0, S1, switch 1, switch 2, capacitor 1, 2 and this is 3 here. So voltage is 8 volt. It is given to us. That is EMF electromotive force V0 is 8 volt here. Switch 1 is initially closed. So we can cross here and switch 2 is open and this is the permittivity ER here and in this side we have permittivity into 1 and we have the 1 microfarad here and this is 1 microfarad. So now we can solve. When the switch S1, we have the 4 option given here. So we have to find which option is correct. So the solution of this question is when S1 is closed, charge on C3, capacitor third. So this is equals to Q3, charge on third is equals to 1 into 8. That is capacitance into. So we know that charge is equals to capacitance into voltage. So from this we get charge on capacitor 3 is 1 into 8 here. So this is equals to 8 microcoulomb. And after closing of S2, switch 2, we get charge on C3, charge on capacitor 3 is equals to, this is 8 into 1 and this is divided by 1 plus relative permittivity, that is ER, and this is ER here 1 plus ER and this is equals to 5 microcoulomb. It is given to us. And now from this we can write here 8 divided by charge on capacitor is 8 we have calculated and this is 5 and 1 plus permittivity, relative permittivity, and this is 1 plus relative permittivity here. So from this we get this is equals to 0.6 plus 0.6 into relative permittivity is equals to relative permittivity. So on solving this, we get relative permittivity is equals to 0.6 and this is 0.4 here. So we get this relative permittivity is 4 by 3, 6 by 4, that is 3 by 2, and we get relative permittivity is 1.5 here. So this is the answer for this question. Now we check which option is correct here. So our option A is correct. Thank you.
Hello everyone, this is our question for today. Let us first read the question. Two charged parallel plate capacitors of capacitance C and 2C are connected in parallel at charge to a potential difference of V. The battery is then disconnected and the region between the plates of the capacitor C is filled with a material of dielectric constant K. The potential differences across the capacitor now becomes what? Initially the potential between the capacitors has been given as V. So we'll write initial potential equal to V. Therefore the total charge in the system will be equal to, we know that for a capacitor Q is equal to CV. Both are charged to V, so Q total, I will write Q T is equal to C, which is charged to V, plus 2C, which is charged to V, or 3CV. This is the total charge initially, and this will remain conserved even if the dielectric is inserted inside any capacitor. When we insert a dielectric in the capacitor C, C changes to K times C. Now let us assume that the new potential between the capacitor is equal to V dash. Final V or final potential is equal to V dash. So we can write QT will be equal to QT dash since charges remain conserved. So we can write 3CV will be equal to 2CV dash plus KCV dash. Taking V dash common, we will get 3CV is equal to V dash into 2C plus Kc. We can cancel C from all the sides. So we will get V dash is equal to 3V divided by 2 plus K. So this is the answer which we had to find. Now let us check which option matches our answer. We see that option number D gives us the answer 3V by K plus 2, which will be correct. Thank you.
Hello everyone. So the question is 5 identical capacitor plates of area A are arranged such that adjacent plates are at a distance D apart and the plates are connected to a source of EMF V as shown in the figure. The charge on plate 1 is and on plate 4 is. So in this question we have to calculate the charge on plate 1 as well as on plate number 4. As this is clear from the figure that 1, 3, 5 are connected to the positive terminal, whereas 2 and 4 are connected to the negative terminal. So if we draw the equivalent circuit diagram, this will be like this. Means 1, 3 and 5 capacitor plates are connected to the positive terminal, whereas 2 and 4 are connected to the negative terminal, and they have given us that area is A and these plates are apart by a distance of D. So now let's proceed with the solution. So there are 4 capacitor plates, each of capacitor C. Then C is equal to epsilon naught A by D, where A is the area and D is the distance, as it is given in the question that they are at a distance of D apart. So the charge on capacitor Q will be equal to epsilon naught A V by D, as we know that charge Q is equal to C V. So since plate 1 is connected to the positive terminal of the battery and is not a part of any other capacitor except first. So the charge on this plate will be equal to Q1 equal to plus epsilon naught AVD. So since plate 1 is connected to the positive terminal of the battery, and is not part of any other capacitor except first, the charge on this plate is Q1 is equal to epsilon naught A V by D. Now we come on to the fourth plate. As we know that plate 4 is common to two capacitor, means formed by the plate 3 and 4 and plates 5 and 4, as it is clear from this circuit diagram. This charge on the plate 4 will be Q4 equal to minus 2 epsilon naught A V by D, and it is connected to the negative terminal. That's why we will put negative sign there. So the plate 4 is common to two capacitor formed by the plates 3 and 4 and the plates 5 and 4, each having charge Q equal to epsilon naught A V by D. Thus charge on plate 4 is Q4 equal to minus 2 epsilon naught AV by D. Negative because this plate is connected to the negative because this plate is connected to the negative terminal. 2. This is our answer. Thank you.
Friend, the question is two protons A and B are placed in between the two plates of a parallel plate capacitor charged to a potential difference V as shown in figure. The force on two protons are identical. Friends, we can see that this is the uniform electric field. Then we can draw that these are the electric field lines and this is uniform electric field, and we can find out the value of electric field inside the plate as suppose there is a point and at this point the electric field due to this positive charge plate will be E1 and due to negative charge plate it will be E2. So we can write that the net electric field E will be equal to E1 plus E2, and we know that E1 is sigma by 2 epsilon naught plus sigma by 2 epsilon naught, then it will be equal to sigma by epsilon naught. That means this is the value of E, which is equally and uniform in this between the plates. So we can write that the force on proton F will be equal to QE. Friends, Q is same for both protons and E is uniform as we have discussed. That means both proton has the same force, then force on two protons are identical. This is true. Thank you, friends.
Hello everyone, let us start with our question. In this question, what is given? The capacitance of a parallel plate capacitor with area A and separation D is given as to be C. Now the space between the capacitor is filled with two wedges of dielectric constant K1 and K2. Okay, we need to find the capacitance of the resulting capacitor. So here it is K1. So here it is given as to be K1. We just write here is K1. Okay, and here is our K2. Now we see that the thickness of the K2 as well as K1, these are varying. Okay, so we cannot directly calculate the capacitance, resulting capacitance. What we need to do, we just need to take a element here. So if we draw, let's say this is our plate, one plate, and this is, let's say, the bottom plate. Okay, now here they are separated from this section. Let's just join a diagonal line. Okay, and here is the potential difference which has been applied. So for example, if we take a small a capacitor, okay, a small capacitor, let's at a distance of x, we just draw a thickness. Okay, let's say this thickness is dx. Okay, this is the thickness. Okay, now it is at a distance of x from this edge. This is the distance x. Now let's say from here to here the portion is y. Let's say this is y and total distance is d. So this would be d minus y. This would be d minus of y. And what would be the total length from here to here? The total length, let's call it as to be L. This is our total length from here to here. Now if we check, for example, if we take this angle as to be theta, and if we take the value of the tan theta, so what would be the value of the tan theta? So we can say that our tan theta would turn out to be, tan theta would be perpendicular by base y divided by x. Okay, and in this bigger of the triangle, if we take this as to be the bigger triangle, so this is our d divided by the total distance is L. So we can say that our x would be equals to y times L divided by d. This would be the value of the relationship between x and y. Similarly, if we differentiate this equation, then we can say that our dx would be equals to dy multiplied by L divided by d. This is the thickness and this is the derivative d. Okay, now what we need to do, we can just find that there are two capacitors, one this and one this. So we can take this, these will be in series. Okay, if we apply a potential difference, so they would be in series. So we can just make these two small capacitors. So let's say this is our one capacitor and this is our another capacitor, and these are connected in series, and these have been applied with a potential difference. Okay, this is our one capacitor, this is our second capacitor. So that in the upper part it is given as to be K2. So we say that it is our K2, this is our K1. So the small capacitance of this portion would be DC2, and for this portion it would be DC1. Okay, so if these are in series, what would be the equivalent capacitance? So we can say that for series connection, the equivalent capacitance is given as to be 1 divided by DC equivalent. Okay, it would be equals to 1 divided by dc1 plus 1 divided by dc2. Now what would be the value of dc1 and dc2? We know that dc1 would be equals to, how is c given? C is basically equals to epsilon a divided by d. Okay, epsilon a divided by d. Now if we are having a dielectrics, so it would be k epsilon a by d. Now for dc1, what is the dielectric? It is k1. Epsilon is epsilon. What would be the area? Area would be what? Area is this area. Okay, if we just draw this, and for example, if b is the width, then this is the area of the capacitor. If b is the total width, then area would be b times dx. So we put the value as b times dx divided by the thickness of the capacitor. For this C1, we can see here one of the thickness is y and one of the thickness is d minus y. So here it is y, and similarly for dc2 it would be k2 epsilon b dx, but the thickness would be what? Thickness would be d minus of y. Now we can put these these terms into this equation. We call this as our equation 1. Now if you put this, what would be the resulting equation which we would be getting? So it would be 1 divided by dc equivalent. This would be equals to, we just write y divided by k1 epsilon b dx plus y divided by, sorry, it would be d minus y, sorry, it would be d minus y divided by k2 epsilon b dx. Now there would be some common term which we can take it to be common. So 1 divided by dc equivalent. So what are the common term? We can take it to be outside. It would be epsilon b dx, and then it would be y divided by k1 plus d minus y divided by k2. So if we take the LCM, so LCM would be k1 k2 here, and the final after taking LCM and the common term, 1 by d equivalent would be 1 divided by epsilon b times dx. So after taking common this LCM, so it would be k1 k2, then k2 would be multiplied here with y, and here k1 would be multiplied by minus y. So if we take our y to be common, so it would turn out to be k2 from this side and minus k1 from this side, and then it would be d times k1, then whole divided by, this would be divided by k1 k2. Now we can write our so we can take the reciprocal, so it would be dc equivalent. So it would be equals to k1 k2 epsilon b, then we just write dx divided by this term. This term is what? Y times k2 minus k1 plus d k1. This is our term. Now we have already calculated the value of dx here. So dx is equals to dy divided by L minus d. So we can just write our dc equivalent once more. So it would be k1 k2 epsilon b. Then what is dx? It is L divided by d. So we just write L divided by d, and we take dy onto this side. Then it would be y times k2 minus k1 plus d times k1. Okay, this is the term. Now what would be b into L? B into L would be what? This is the total length. L is the total length and b is the width. So what is b into L? It is the area of the this plate. Area of the plate would be b into L. So we can just write in place of b into L as a. Then our c would be defined as the integration of dc equivalent. And what would be the common term? We just take it to be outside. Then it would be k1 k2 epsilon. Then b into L, it would be the area divided by d, and we can integrate this term, dy divided by k2 minus k1 y plus d times of k1. Okay, so what is the limit of y? So if we see, y would be varying from here, y would be 0, here y would be equals to d. Here we can see that y would be 0, here y would be equals to d. So we can put the limit as 0 to d. So limit would be from 0 to d. So it is a simple integration. So the answer would be in terms of log ln. So c would be equals to k1 k2. We just write once more k1 k2 epsilon a divided by d. What would be this integration? It would be ln k2 minus k1 y plus d times k1. So it is a linear function in the denominator. That is why it is the integration, and we can put the limit from 0 to d. But there is a coefficient k2 minus k1 for y, so we need to divide it by the coefficient. So we are just writing the coefficient here, k2 minus of k1. Now if you put the limit, what will happen? So our c would turn out to be k1 k2 divided by k2 minus of k1. Then it is epsilon a divided by d, and now it would be we can put the limit. So ln k2 minus k1 into d, if we put the value, so what will happen? So there would be minus k1 into d, and there is plus k1 into d. So this term would be cancelled, and it would be k2 d divided by, if we put the value as 0, so this whole term would be gone, so it would be just d times of k1. So from numerator and denominator, this d thickness would be gone, so it would be c k1 k2 divided by k2 minus of k1. This is the one term. Then epsilon a divided by d, then ln k2 divided by k1. Okay, so this is the final expression for our capacitance. K2 minus k1 k2 divided by k2 minus k1, epsilon a by d, ln k2 divided by k1. This is the final capacitance of our question. Hope you understood the solution. Thank you.
Hello everyone. So the question is, two square plate metal of side 1 meter are kept 0.01 meter apart like parallel plate capacitor in air in such a way that one of their edges is perpendicular to the oil surface in a tank filled with an insulating oil. The plates are connected to a battery of 500 volt. The plates are then lowered vertically into the oil at a speed 0.01 meter per second. Calculate the current drawn from the battery during the process. So in this question we have to calculate the current drawn, and they have given us the dielectric constant of oil 11, epsilon naught is 8.85 into 10 to the power minus 12 per nm square. So this is our tank which is filled with the oil, and these are our parallel plate C1 and C2 and apart by a distance d which is equal to 0.01 meter. So when they are lowered in the oil, then the part which is covered with the oil is x, and the remaining will be in the air. So that will be L minus x. The length will be L minus x, as x length is dipped in the air in the oil, and L minus x will be in the air. So now we will proceed with the solution. So they have given us L is equal to 1 meter, and the separation between the plates D is equal to 0.01 meter, and dielectric constant of oil K is equal to 11. EMF of battery V is equal to 500 volt. So we will assume that let at a time instant t length x of the plate be in oil, and remaining length L minus x be in air. So the this configuration is equivalent to capacitor of capacitance. So value of C1 will be epsilon naught L minus x by d length, and the remaining length which is in the air, and the value of C2 is equal to K epsilon naught L X by D. So as it is given that they are connected in a parallel, so the value of C means equivalent capacitance will be sum of these two, C1 plus C2. So this will be equal to epsilon naught L by D. We have taken it out common. This will be L K minus 1 X L plus K minus 1 X. Now we know that the charge on the capacitor, is Q, which is equal to C V, and the current through the circuit is I equal to dk I dt, and we can write it as Q equal to CV, so we can write it as V dc dt. So this value will be equal to V epsilon naught V by D, where value of small v is equal to dx by dt, and this is the speed at which the plates are being lowered. Now we will substitute the values. So the current I to capital V, this capital V, the value of this capital V is 500, EMF 8.85, value of epsilon naught into 10 to the power of L is 1, value of K is 11 minus 1, and the value of this means speed at which the plates are being lowered is 0, 0, 0 by D, 0.01. Now the value of 0.425 into 10 to the power minus 9 ampere. So this is our answer. Thank you.
Hello, we are given with a question, and the question says two parallel plate capacitors A and B have the same separation D equals to this much between the plates. The area is this and this for A and B, right? A slab of dielectric constant K equal to 9 has dimensions such that it exactly fills the spaces between the plate of capacitor B, right? The dielectric slab is placed inside A as shown in figure. A is then charged to potential difference of 110 volt. Calculate the capacitance of A and energy stored in it. The battery is disconnected and the dielectric slab is moved from A. Find the work done by the external agency in removing the slab from A. The third question, the same dielectric is now placed inside B, filling it completely. The two capacitors A and B are then connected. Calculate the energy stored in the system. So these are the processes, three processes, right? So in first, what we are saying that what is the capacitance? Since the capacitance would be equal to epsilon naught, since it has area exactly half to that of this one, the area of A, right? So we can write that epsilon, it fits half area by D, right? So that is plus the capacitance of this areas. So that is the empty area is A by 2, right? And the distance is D itself, right? Then next, where the dielectric is placed, that has K times epsilon naught A by 2 by D, right? So from here, when we calculate, when we substitute all the values, that is K equal to 9, epsilon equal to 8.85 into 10 to the power minus 12, and this value is given as 8.85 into 10 to the power minus 4, and A by 2, that is area is 0.04 by 2, right? Since it fills this completely, right? It fits the B block completely, so the area would be equal to 0.02 for that one and 0.18 for this one. So that turns out to be 0. Why 0.18? Because the leftover area 0.02 into 9, that is K. Area into K would be equal to A by 2 into K would be equal to 0.18, right? So epsilon naught D A by 2 is taken common, and we can calculate this value, and this value turns out to be equal to 0.2 into 10 to the power minus 8 Faraday, right? Now the next question we have asked is, we have to find the energy stored in it, right? So the energy stored initially is half CV square, so its capacitance is 0.2 into 10 to the power minus 8 into what is voltage, 110 square. So that turns out to be 1.2 into 10 to the power minus 5 joules, right? The second question asks us if we move that dielectric, right? So the charge is, so what we have to find, the battery is connected and this is second, right? Then dielectric slab is moved from A, find the work done. So since the charge were CV, right, the new capacitance would be equal to epsilon naught A by D, right? Correct. So we can do what we can do is, now we can find the work done. Delta W would be equal to Q square by 2C dash minus Q square by 2C, since the voltage would remain the same. So this value turns out to be that this is CV square, right? So we can write that to be equal to, when we substitute all the values, this value turns out to be equal to 4.84 into 10 to the power minus 5 joules. This is the total work done. The third question is, when we connect that to this one, A to B, and B is being filled by the dielectric constant, right? So what we can do is, we can find out, right, the capacitance, new capacitance of this. So that would be, so first of all we will calculate CB, right, the capacitance on B. So that would be equal to K epsilon naught A by D, since it fits that area completely, right? So that turns out to be equal to 1.8 into 10 to the power minus 9 Farad, and here also it was 0.4 into 10 to the power minus 9 Farad C dash, right? So our C dash A, so the total capacitance would be equal to, since they are in parallel condition, 0.4 plus 1.8 into 10 to the power minus 9, right? So that turns out to be 2.2 into 10 to the power minus 9 Farad. This is the total capacitance of the system, right? So energy stored would be equal to Q square by 2C, right? So Q is since equal to 2.2 into 10 to the power minus 7 the whole square by the CV, right? The value of CV was equal to 2.2 into 10 to the power minus 7 coulomb, right? So this by 2 into C, that is 2.2 into 10 to the power minus 9. So this turns out to be equal to 1.1 into 10 to the power minus 5 joules. This is the energy, right? This is the work done. This is the energy for the third answer. and this is the energy stored and the capacitance of A. Thank you.